Good afternoon, everybody. Welcome to the course on Principles and Practices of Process Equipment and Plant Design. Currently, we are going to discuss Week 10 Previous Year Assignment Solution of NPTEL Questions. Myself, Suraj P. from Chemical Engineering Department, IIT Kharagpur. So, the first question is, consider the following statement. Three statements are given regarding pinch point calculation in heat exchanger network. Statement 1 is no heat transfer occurs across the pinch temperature. Statement 2, no use of cold utility below the pinch temperature. Third statement, no use of hot utility above the pinch temperature. From the pinch principle, the necessary and sufficient condition to achieve minimum utility consumption targets for a process is so they are asking three statements are given from the above three statement, which of the condition is the necessary and sufficient condition for obtaining minimum utility during pinch point calculation. So the answer for this one, correct answer for this one is option A. That is that no heat transfer should take place across the pinch temperature. And the statement 2 is actually false, because the assumption that the principle that is necessary for pinch principle is that no use of cold utility above pinch temperature, but here it is written below pinch temperature, and no use of hot utility below the pinch point. So the correct answer for this one is A. Only statement 1 is true. So I am writing here the necessary conditions. Necessary condition to achieve minimum utility. First condition is no heat transfer across the pinch temperature. Second statement is no use of cold utility above the pinch point. And the third statement is no use of hot utility below the pinch temperature. So let's see question number 2. With the decrease in delta T mean, the requirement of hot utility dash and that of cold utility dash. So that delta T with decrease in delta T mean how it affects the hot utility and cold utility, requirement of hot utility and cold utility. Actually the hot utility required will be decreasing, and the cold utility required will be also decreasing with increase in decrease in delta T min. So the answer for this one is option B. We know that this is calculated by plotting temperature versus enthalpy of the stream. So on drawing this hot composite curve and cold composite curve, we need to find the minimum temperature difference, that is delta T min. So if there is a decrease in delta T min, the hot utility required will decrease and the cold utility required will also decrease. So which of the following statement is true regarding pinch point estimation using problem table algorithm? So the problem table algorithm is a method for estimation of a pinch point. For that we need to for that some data of the hot temperatures of hot and cold streams are provided. So the correct answer options are the start and target temperature of all hot streams is decreased by delta T min by 2. The start and target temperature of all cold streams are increased by delta T min by 2. The shifted hot and cold composite curves touch each other at pinch point. Option D, all of these. Actually the answer for this one is option D. Like for obtaining the shifted start and target temperature for hot stream, we need to shifted target temperature we need to subtract delta min by 2. Shifted target temperature is given by Ts star, which is equal to Ts, that is actual temperature of stream, minus minimum temperature difference by 2. This is for hot stream. And for cold stream, the shifted target and supply temperature are given by initial supply temperature plus delta T min by 2. This is for cold stream. So these two statements are true, that is the shifted start and target temperature of hot stream is decreased by delta T min by 2, and for cold stream it is increased by delta T min by 2, and both of the curve, that is hot and cold composite curve, touch each other at pinch point. So all the three statements are true. Next question, heat exchanger network design can be targeted to minimize option A, number of heat exchanger units, option B, total area of heat exchangers, option C, utility requirement, option D, all of these. Actually the options given here are wrong, because only two at a time can be minimized in a heat exchanger network at a time. Like either we can minimize number of heat exchanger required and total area, or we can minimize number of heat exchanger required and utility requirements. So either two of the above can be minimized from heat exchanger network design. That is, either number of heat exchangers or number of heat exchanger and heat transfer area or number of heat exchange or total area of heat exchanger or utility requirement, because these are interrelated. That is, uh, the utility is directly, heat exchanger is a type of utility, so these are interrelated. So either these two can be minimized or these two can be minimized. All at a time cannot be minimized because they are related. Question number 5. Which of the following statement is true for pinch point analysis of two-stream flow? Option A, it uses temperature enthalpy plot. Option B, the minimum temperature difference between hot and cold stream delta T min is the governing parameter of this analysis. Option C, the delta H for hot streams and cold streams remain constant during this analysis. Statement 1 is true, that is, pinch point analysis uses temperature enthalpy plot. Statement 2 is also true because delta T min, that is the minimum temperature difference between hot and cold stream, is the governing parameter for the analysis. And statement 3, that is, the enthalpy of hot stream and cold stream are constant during the analysis. So all the options are true. So correct answer is option D. Next one, which of the following is not a feasible criteria for stream matches at pinch? N out is greater than N in, NH is less than or equal to NC, and CPH is less than or equal to CPC in hot section. NH is greater than or equal to NC, and CPH is greater than or equal to CPC for cold stream. And CP out is greater than CP in. First let us see what is the feasibility criteria for pinch analysis. First one is N out is less than or equal to N in. Second one is NH less than or equal to NC, and CPH less than or equal to CPC for a hot section. Third one, NH is greater than or equal to NC, and CPH is greater than or equal to CPC in the cold section. The fourth condition is Cp out is greater than or equal to Cp in. Okay, so here the option A written is violating the feasibility criteria. So then a non-feasible condition is option A. So answer for this one is option A. So now let's see the question number 6. Using the following stream specification table, assuming delta T min equal to 20 degrees Celsius, the shifted supply and target temperature, supply temperature for the stream 1 and shifted target temperature for stream 3 are. So we need to know the what is shifted target and shifted supply temperature. Shifted supply temperature and target temperature for cold stream is obtained by addition of a minimum temperature difference, half of minimum temperature difference. So here stream 1 is a hot stream, so we need to subtract the minimum temperature difference, half of the minimum temperature difference. First they are asked shifted supply temperature for stream 1. This is the actual supply temperature, that is 170. So for stream 1, which is a hot stream, the actual shifted supply temperature is given by Ts, which is equal to 170 Celsius. So the shifted supply temperature is given by Ts star, which is equal to Ts minus delta T minimum by 2, which is equal to 170 minus 20 by 2, that is 160. And for cold stream, next they are asked for shifted target temperature for stream 3. So let's see what is stream 3. Stream 3 is a cold stream. So for cold stream we need to add half of delta T min. Shifted target temperature they have asked. The target temperature for stream 3 is 90 degrees Celsius. So the shifted target temperature is given by T star, which is equal to Tt plus delta T minimum by 2, which is equal to 90 plus 20 by 2, which is 100. So the answer for this one is 160 and 100. So along with this we need to find the next we can find the pinch temperature. So we can see how pinch temperature is calculated. Using the values from the table above. First we need to write the stream number. Next we need to write the type of stream. Next the supply temperature, which is Ts. Next is the target temperature, which is Tt. Next is heat capacity, Cp. Next we need to find the enthalpy from heat capacity, delta H, which is equal to Cp into Tt minus Ts, target temperature minus supply temperature. Next we need to find the shifted supply temperature Ts star and shifted target temperature Tt star. So stream number 1, which is a hot stream, its supply temperature is 170, target temperature is 90, and the Cp value is given by 20. And stream 2 is a hot stream, supply temperature is 140, target temperature is 50, and the Cp value is 40. Stream 3 is a cold stream, its supply temperature is 50, target temperature is 90, and the Cp value is 80. For stream 4, which is a cold stream, the supply temperature is 30, target temperature is 110, Cp value is 30. So for finding shifted target and supply temperature, we have already told how it is done. Like Ts star can be obtained from, for hot stream it is subtracted by delta T min by 2, and for cold stream it is added with delta T min by 2. So on doing that, we will get shifted target supply temperature as 160, that is 170 minus 20 by 2, delta T min is 20, and shifted target temperature is 80. Similarly, for other streams we can write it as 130, 40. For cold stream it's added with delta T min by 2, so 50 plus delta T min by 2 will get 60, and this one is 100, 90 plus 20 by 2, this is 40, and this is 120. Now after that we need to draw the table for finding pinch temperature. So first we need to mark all the temperatures, that is initial temperature is 160, maximum temperature is 160, then comes 130, then comes 120, then comes 100, then comes 80 Celsius, then 60, and finally 40. So these temperatures are obtained from the all the shifted supply and target temperature is to be marked using a line. So all these values in a decreasing order. In decreasing order, that is maximum is 160. So you have written 160, then comes 130, then comes 120, then 100. So similarly we have written all others in decreasing temperature order. Then we need to mark the heat capacity values, that is Cp values. So the first stream is in the stream number 1, it is cooled down from 160 to 80. So from 160 to 80 cooling take place, and the Cp value is 20. Next, for stream 2, cooling takes place from 130 to 40. So this is the stream 2, and its Cp value is 40. Then for stream 3, it is heated from 60 to 100. 60 to 100. So this is the stream 3, and its Cp value is 80. Then for stream 4, which is heated from 40 to 120. So it is also a cold stream, which is heated from 40 to 120. And its Cp value is given by 30. So let us mark this as stream 1, this is stream 2, this is stream 3, and this is stream 4. So next we need to do the calculation, that is difference of Cpc and Cph in a particular line, that is sigma Cpc minus sigma Cph. So here it is a hot stream, or here no cold stream is in this line, no cold stream is present. So Cpc minus Cph will be going to be minus 20. Here also no cold stream is present, only hot stream is present. So 0 minus 20 minus 40, so we will be getting minus 60. Here actually one cold stream is there, whose Cp is 30. So 30 minus 2 hot stream, 30 minus 20 minus 60, which we will get as minus 30. Here we have 1, 2, 4, 2 cold streams and 2 hot streams. So we need to do 80 plus 30 minus 40 minus 20, which we will get as 50. Here we have 3 streams, 2 cold and 1 hot stream. So 80 plus 30 minus 40, so we will get is 70. And here we have 2 streams, 1 hot and 1 cold. So 30 minus 40 we will get as minus 10. Next we need to find the enthalpy change in each stream, which is given by delta H, which is equal to delta Cp into delta T. That is, delta T is the temperature difference between these two streams. Suppose this is 160 and 130, so here delta T will be 30. So here we need to multiply this 30 with minus 20, so we obtain minus 600. Similarly here temperature difference is 10, so 10 into minus 60 will be obtaining minus 600, and here minus 30 into 20, which is again minus 600. Similarly all the other values we are writing. This stream it is coming as 1000, this stream is coming as 1400, and this stream it is coming as minus 200. So the enthalpy calculation is finished. Now the next step is we need to add 0 kilowatt from the top of the stream number cascade number 1. So we are adding 0 kilowatt from the top, which we are after adding 0 kilowatt from the top, this we will obtain 0 minus 600. So here plus 600 will be coming, and this plus 600 will be added to this next stream enthalpy, that is minus 600. So 600 minus 600 we are obtaining as 1200 plus 1200. Plus 1200 will be evolved from the above stream to next stream, that is which is also minus 600. So here also 1200 minus 600 we are obtaining 1800, plus 1800 will be evolved, which is going to the next stream, which is 1000. So 1800 minus, we need to subtract here because it is positive, so 800 will be released. 1800 minus 1000, which is 800. So next to the next stream 1400, 800 minus 1400, which is minus 600. Then we need to add this to minus 200. Then 400 would be released. Actually here we didn't obtain any enthalpy value as 0, so we need to see among this one which one is the least negative. So here the least negative is 600, so we need to add this 600 into the next cascade number 1. So adding 600 kilowatt to the top stream of cascade number 1. So this 600 minus 600 we need to do. So here at 1200 will be evolved, 1200 will be evolved, then which will be added to this. So 1200 minus 600, we are obtaining 1800, plus 1800 will be evolved. Which will be going to next stream, that is minus 600. So 1800 minus 600 we are obtaining as 2400. Which will be added to 1000. So 2400 minus 1000 we are obtaining as minus 1400. Not minus here, 2400 minus 1000 we are obtaining as plus 1400. The next one we need to add 1400 minus 1400, we are obtaining as 0. So here the location of pinch point is obtained by where the 0 addition of enthalpy is seen. So here the location of pinch temperature is found out. So here the location of pinch point is 60. So the pinch temperature we are obtained as 60 degrees Celsius. For calculation of cold pinch and hot pinch, we need to add delta min by 2 and subtract delta min by 2. In case of hot pinch, if we need to get a hot pinch, we need to subtract delta T min by 2. And for cold pinch we need to so the cold pinch temperature is 60 degrees Celsius minus delta min by 2, delta T min by 2, which is equal to 50 degrees Celsius is the cold pinch temperature. And for hot pinch temperature, which is equal to 60 plus delta T min by 2, which is 60 plus that is 70. So this is the hot pinch temperature and cold pinch temperature. And for throughout the problem calculation, we have taken the value of delta T min as 20 degrees Celsius. So I hope that this is clear to you, how to calculate the shifted target temperature and shifted supply temperature. Also how to make the table from the for the calculation of pinch temperature. So I will explain once more. First we need to calculate all the shifted temperature from the given supply temperature and target temperature. For hot stream we need to subtract the minimum temperature difference, that is delta T min, and for cold streams we need to add the delta T min, half of delta T min. Then we will obtain this shifted supply temperature and shifted target temperature represented by Ts star and Tt star. Then we need to see all this temperature and sort it according to the decreasing order of temperature. So here maximum temperature is 160 and minimum is 40. So we need to sort all this temperature in decreasing order of temperatures. Then we need to mark all the streams, like for stream 1 it's a hot stream which is cooled from 160 to 80. So we need to mark this 160 to 80 stream 1. Then for stream 2 130 to 40, 130 to 40. Then stream 3 it is heated from 60 to 100, 60 to 100. Then we need to mark all the CP values together with them, like all the specific heat values also should be marked. Then we need to find the difference between CPC and CPH in each streams. How many streams are passing through that? In that section we need to find out and do the calculation accordingly. So here only one stream is passing and it is a hot stream, no cold stream is present, so we need to do 0 minus 20 minus 20. And similarly here there are 4 streams passing, 2 hot and 2 cold streams, so we need to add 20 plus 40 minus 80 minus 30, so we will be obtaining 50. Similarly all the sections are marked. Then next we need to find the enthalpy change, delta H. Delta H is obtained by this CPC minus CPH into temperature difference, that is here delta T. Like here the temperature difference is 160 minus 130, which is 30. So 30 into this minus 20 we will obtain minus 600. Similarly we need to, like here the temperature difference is 20, 120 minus 100, so 20 into minus 30, this is minus 600. So all the enthalpy values are tabulated, followed by next we need to add 0 kilowatt from the top of the stream number 1, not stream number 1, that cascade number 1. So this 0 minus 600, we will obtain plus 600. Then this 600 should be subtracted from next stream, that is 600 minus 600, this is 1200. Then 1200 minus 600, 1800. Then 1800 minus 1000, which is 800. Similarly we need to do all the calculation and find whether 0 kilowatt is obtained in any point of calculation. But in first step we haven't obtained any heat value corresponding to 0 kilowatt. So we need to find out the minimum least negative value here, that is here the least negative value is minus 600. Then we need to add this minus 600 from the top, and after adding minus 600 to this we will obtain 1200. Then 1200 minus 600 we will obtain 1800. Similarly the procedure is repeated, and here we can found out that we came to found that after some between 60 and at the point of 60 we obtained 0 kilowatt, of enthalpy. So this is the location of pinch point, and the corresponding pinch temperature is 60 degrees Celsius. Next we can find the hot pinch and cold pinch. In case of cold pinch, we need to subtract the pinch temperature with delta T min by 2, and for hot pinch we need to add pinch temperature with delta T min by 2. So this is the procedure for calculation of pinch temperature. So next question, choose the correct option among the following. Statement 1, the tick of heuristic is used to estimate the minimum area target for the network. Statement number 2, the tick of heuristic is used to estimate the minimum number of heat exchanger unit. So the options are only statement 1 is true, option 2 only statement 2 is true, both the statement are false, and option D, both the statements are true. So here the correct answer is that tick of heuristic is used for estimation of minimum number of heat transfer units. So statement 2 is true. So option B is the correct answer. Next one, match column 1 containing some valves with column 2 with their characteristic. First, gate valve. Like we know that gate valve is used either in completely open mode or completely closed mode. So option A, gate valve can be operated only in completely shut off or fully open position. So gate valve is also called as on off valve. Next one is non-return valve. Non-return valve is also known as check valve. Like it allows the flow of fluid in only one direction. So it do not allow the flow in other directions. So check valve, in a check valve, direction is marked. Check valve or NRV, direction is always marked, and the flow happens in only in that direction. So here the option B is corresponding to 4. Non-return valve does not allow backflow. It will not allow backflow. Then option C, globe valve. Globe valve is used for controlling the flow. With help of globe valve we can regulate the flow rate of a stream. So C is corresponding to 2. Then diaphragm valve. Like diaphragm valve does not allow the leakage through its gland, but in case of globe valve and gate valve, the leakage is possible after usage for longer time, but in case of diaphragm valve, leakage is minimum. So the correct answer will be A will be 3, A will be 3, B will be 4, C will be 2, and D will be 1. So the correct answer will be option D. So thank you for listening to this class. If you have any doubt in this problems, you can mail to me, or you can post in the discussion forum of the NPTEL portal, SWAYAM portal. Thank you for listening.